day number 7 in the advent of code. We just need to run an update. We've all been there. I think system update please, pretty please with sugar on top is just the best command I have ever witnessed. Kudos to the author. Our job is to actually understand the console output and build a folder directory out of that, so that later on we can actually calculate how much disk space there is, or how much disk space is still needed for the update. Let's go to the code. In terms of testing, we're just using the input provided by the task, and also the 2 specific test cases that were also provided. The solution itself is short, but that's only because all of the logic is hidden away in directory3 class. Directory3 class does 2 things mainly. So first, it describes the actual look of the disk with all of its directories and files. To understand the console output, we need a few details, and those are just constant strings that you see in here. I've created 3 private enums that will just help us out traverse the code. First describes whether the line is a command or rather the output of a command. Next one describes whether the command is actually one of changing the directory or listing one. Lastly, we differentiate if we want to change the directory, whether we go up, down, or to the main. We need a way to start looking through the tree, and main directory is exactly our root. The private class of my directory consists of a name, a possible parent, because the main directory doesn't have a parent. It also lists all of the subdirectories and all of the files placed right away in this particular directory. We also have a private record for my file, because we will not be using it outside of directory3. I've placed parsing the console output in directories3 constructor. In the beginning, we are creating the main directory, and we're also placing a pointer to the current directory. For each of the console output lines, we determine the type of that particular line. In case it's a command, we want to process it as a command, or if it's only an output, we want to process it as an output. In the output of process commands, we can actually change the current directory. We may want to move the pointer to a different directory. Whenever we are sure the line is an actual command, we can get rid of its first part and focus on the command itself. Once we complete that, we're figuring out what command type it is. Change dir without keyword is either a slash to go to the main directory, 2 dots to go up 1 level, or a name of the directory if we want to go down a level. Therefore, what we return is a new pointer to the current directory. If the command, however, was a listing command, we don't care about this particular line, we can just skip it. To process a change of the directory, first we need to understand which direction we are going. Once we get the direction, all we need to do is return the new current directory. So it's either main directory or the parent of this particular directory, or we're going down into a specific directory, which we can find in subdirectories list. We're back again at the constructor level. We've discussed already what happens to the commands. Now let's take a look at the output lines. In case of output lines, we only have 2 possibilities. We either will add a new subdirectory or a new file. Completing this for each loop for the lines of the console output, we are completely done with building the directory tree. Now we can traverse it. First thing we want to return is the sum of sizes of the directories smaller than a parameter. Do bear in mind the logic behind is actually wonky by design. It can calculate the same directory at least a few times, and more importantly, it can take into consideration the same files multiple times. But this is the domain we are living in. We don't try to fix it, but we try to accept it, and we try to design our solution accordingly. Now we will be traversing this directory tree, calculating however much space the files take. Whenever we will find a directory which size is smaller than the maximum size parameter, we will add it into results dictionary. Once we have all of those directories in the results dictionary, it's quite easy to run sum on them. Get_size of dir and add to list is a function that is recursive. First, we calculate the size of the files in this particular directory. Then we calculate the size of subdirectories of this particular directory using recursive algorithm. Whenever the sum is smaller than the maximum size we want, we'll add it to results. This approach is a bit debatable, because we might as well just add everything to results and then filter it afterwards. Part number 2. We're looking at the same directory tree. Our job is to calculate the total sum of used space. We need to figure out the smallest directory that we could remove to have enough space to run the update. To do that, we once more use the get_size of dir and add to the list. But this time around we are using disk size as a maximum size of the directory. So the results will contain actually all of the directories possible and their sizes. Then we calculate disk space occupied, space required to be removed. Out of all of the possibilities then, we take out the smallest one. Let's run the output. And that's it. If you're wondering why for the get directories size sum at most I used unsigned integer, all of the sizes in here doesn't really make sense in negative. That's why unsigned integer is a perfect fit for the domain. Thanks guys, I hope you enjoyed TDD and C# with Advent of Code. And as always, we can do better as a pack. Bye. Before let's check out the my directory helper class. Let's check out the my directory help. Out of all of the results, we leave only those and from all of those possibilities we take the minimum one or the lowest one or the